designed. It's a relatively simple affair, but we think you should be able to complete it in about an hour. It's split up into 4 kind of sections. The first one is the setup. So we want you to sort of download the code we've prepared for you, set up the environment, type out the API keys, set up the services, pre-download what you need to. We've pre-deployed a load of transformation and GPT models already in Azure for you. There's a GPT-4o model. We've not splashed the cache out on the O1s yet. We're then going to explore the demo app we've built. We're going to do a little bit of retrieval augmented generation. We're going to vectorize some PDFs. We're going to do some nearest neighbor searching, which I'll explain a little bit more detail in a second. We're then going to slap an LLM on the end of it and make that nearest sort of find, command F and search a little bit neater. We're going to use an open AI language model to give us a little bit more kind of natural language responses, and it's not just verbatim copy from your source material. And then hopefully you're going to experiment around with some ideas that you've got on our base application. Our base application looks like this. Isn't that fantastic? It's incredibly simple. The idea is that you can pick a PDF or a Word document, you can upload the Word document, and then you can search for something in the document because Command F is too simple. It's just 2 containers. There's a Flask app that has all our logic and fancy UI, and then there's Elasticsearch that we're going to use as a vector database. The vectorization and searching is all done in Azure's OpenAI services through 2 models, a text embedding and a GPT-4 model. And we're going to replace our nearest neighbor searching with the GPT-4 in there, so we get to do a little bit of playing. I've mentioned retrieval augmented generation. A quick recap on what that is, and it's there's 3 things we need to have a quick chat about, and this is the first one. It's a technique that combines kind of 2 components. So the idea is that you can take your data, you can slice your data up into little bits, and then you store it in a vector database. Elasticsearch being one of them. There's a few. We then can search. We can then tell our generative models, our ChatGPT kind of things, to answer a question with some context, and that context is what we've stored in our retrieval system. And it just provides a database of things that we can search. Nice and easy. Secondly is vector searching. So we've mentioned that a couple of times now. This example is heavily simplified, so just bear with. If you imagine a PDF called Barbecuing for Beginners, there might be some things in there, like bits about cooking, hygiene, and probably building a barbecue. We take that data, we slice it into bits, and then we can plot it on, in this example, a 2D plane. The words that make up those things are kind of clustered in bits across a plane. We can add another thing. So if you imagine the Gordon Ramsay Kitchen Nightmares Season 1 transcript, it's going to be broken down into a few things. And we can see that there's some things that overlap, there's some outliers. We can add another document to it, like a farm equipment operational manual. And we're going to see, again, more overlap, more outliers, but we've now got quite a busy graph. And if we start asking it questions like, how do I cook a chicken? Tom, do you want to? We can see that starts to plot an overlapping area. With that overlapping area, we can then now feed that into our model. We can tell it it's a helpful assistant. We can tell it to answer some questions, and we can tell it to include the text that is in that overlapping bit. The third thing that we need to be really, really key about and how we slice up that data is chunking, which I'm going to hand over to Tom to explain and then get you all started on this workshop.
So for those that don't know me, I'm Tom Black. I'm our Azure Platform Capability Lead at BGSS. So I'm going to explain chunking with something that's very dear to my heart, and it's a cake recipe. May or may not be taken from ChatGPT, so if it's not quite right, bear with. So as Simon was saying, the data that we feed into our applications is really important, and that's what's going to give us good results. So we need to feed in really small bits of information because our large language models only support a certain context window, so we can't feed in massive PDFs. If we start to feed in too much information, we're going to start seeing it make things up and get confused over which paragraph it's getting information from and whatnot. If we feed in too small, it's not going to quite have enough information, might give us a partial answer. So if we look at this, the first example, we've got sentence chunking, and that, as you might expect, each sentence in our cake PDF recipe has just been split and we've got 5 chunks. But if we look at semantic chunking and we think about what Aiden's just talked about with vector searching, we've kind of taken things that roughly have the same intent. So if we look at section 2 with mixing ingredients, we've got mixed flour, sugar, blah, 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 blah. So if we ask the question to our knowledge search application on how do I make a cake, if we're using sentence chunking, it might come back with, oh, you mix flour, sugar, and baking powder in a bowl. It's going to be a pretty nasty cake. But in the second one, we get the full set of instructions. And so as we're building this application today, it's really important to think about how much information we're passing in when we're doing the chunking. Now, for sake of simplicity, we've scrapped both of these and we're just taking 100 characters. But if you want, have a play, come and grab me. Be interested to see what we can put together. And now it's time for the fun bit. So over to the table, Leeds, and time to start hacking.